Hello, hello. All right. Remember last time the notes were really long and I promised you they wouldn't always be long? Promise fulfilled. Today's going to be pretty short. So I'm going to try not to talk more than I need to talk because I want to keep this video short to make up for the last one. All right, so pause me and take a minute to copy all that stuff down. Okay, so in Algebra 2 trig, we talk about when there's a coefficient in front of the function. So comparing like these two things, what does that do to the graph? But we don't talk about what it looks like when there's a coefficient inside of the function. So that's review, and this is new. So the difference here is that the coefficient is attached to the x, whereas here the coefficient is actually kind of attached to the y, isn't it? Because y equals f of x. So f of x represents y, right? So this, the coefficient is attached to y, and this, the coefficient is attached to x. That's a 4. I was going to change it to a 3, and then I remembered why I had it as a 4 after I changed it to a 3. So I had to change it back. So first thing I want you to do is give me the ordered pairs that we talk about, the 3 ordered pairs for y equals x squared. Pause me, please. Okay, so we have 1, 1, 0, 0, and negative 1, 1. You have those in your brain, I'm sure of it, from Algebra 2 trig, but there's no magic. It's just simply plugging in a 1 into x squared and plugging in it. Oops, I said 0, 0. I didn't write 0, 0, right? Plugging in a 0 and plugging in a negative 1. Now, without plugging in, I want you to remember what this 2 means. What is that 2 going to do to the function? So that 2, we take the y value and we multiply by 2, the y value of each ordered pair. So I'm going to take these same ordered pairs. So that's why I mentioned f of x is the same as y. We just said y equals f of x up here. When the number is in front, we multiply the y value. Yeah? Here, well, I don't want to give too much away. I almost just gave away the punchline. All right, so the x value stays the same, but each of these corresponding y values gets multiplied by 2, right? You guys remember that from Algebra 2 trig, I'm sure. Okay, so over here, I want you to write the 3 ordered pairs that we generally memorize for the square root of x. Pause me, please. Okay, so 0, 0, 1, 1, and 4, 2. And I'm sure at some point we've discussed why we pick these x values, but just in case we haven't, again, I'm making these videos in the summer, so still. School hasn't started yet, so I don't know what we will have discussed by the time you watch this video. We skip 2 and 3. Yeah, we skip x values of 2 and 3 because we don't want to take a calculator out. Square root of 2 is like 1.414, and square root of 3 is 1.87 or something like that. I really don't remember, but I want to plug in values that I can get integer y values for, right? So, and then also we don't do negatives because we can't take the square root of a negative without getting into the imaginary world. And like I said in a previous video, we're not going to be in the imaginary world except for one chapter, and it will be very clear in that chapter. So the question is, what does this do to the graph? So what I want, so it's attached to the x, right? So this one, the 2 was attached to the equivalent of y. So the y values changed, and the x values stayed the same. So over here, since it's attached to the x values are going to change. So let's look at the y values here, those same exact y values. So again, I want to reiterate. Sorry about that, guys. Apparently I have not had enough coffee today. It's a weekend. I'm making this video on a weekend. How lame is that? The weekend before summer starts, you're making a video? I know, right? And it's a beautiful day outside. I should be like outside enjoying the weather. All right, I'm gonna stop blathering on. Okay, these x values are exactly the same because this is changing the y value, okay? Over here, this is gonna change the x values, so the y values are gonna stay exactly the same. So here's what I want you to do. I want you to pause me for a couple minutes. I want you to think, how can you get out a 0? What would you plug in for x? How can you get out a 1? What would you plug in for x? And how can you get out a 2? what would you plug in for x? So pause me, and I really, really, really want you guys to think about this. Some of them are super easy. Maybe one of them takes a little bit more thought, but I want you to try and get all three of them, okay? So pause me. Okay, so the only way to get a 0 is a 0, right? I need 0 under a radical to get a 0 in the answer for y. Let's jump here. How do I get a 2 out? Well, the square root of 4 is equal to 2. So I need the x value to be 1 so that this is turning into the square root of 4, right? What about here? How do I get a 1? Oops, can you see that? I don't remember if in these videos you can see the little buttons on my screen. Okay, you could solve that equation. I would much rather you reason through it instead of like squaring both sides and then dividing by 4. But if you needed to, you could square both sides to get rid of the radical and then divide by 4 to get the x by itself. But what is it that we need under the radical? We need a rad 1 to equal 1, right? So what does this x value have to be in order to make this a 1? Well, the x value has to be 1/4, right? So now compare these x values from here to here, each one. Well, 0, that's the same. So I don't know what I did. I don't know, maybe I didn't do anything. From 1 to 1/4 and from 4 to 1, what is the rule? Okay, so I can't say, oh, from 4 to 1, I just subtracted 3. Because that doesn't work here. It has to work for both of them. So the question is, how do I get from 4 to 1 and also, or that will also get me from 1 to 1/4? You've probably already answered that in your head because I'm probably over explaining it, but I want to make sure I don't leave anyone behind. And since we're not in class together, I can't see if you're getting this. So I might over explain a little bit. Multiply that x value by 1/4. This times 1/4 gives me this. This times 1/4 gives me this, and this times 1/4 gives me this. So take a second and copy down this general rule that I've written and the example. Pause me. Okay. So general rule, when there is a coefficient inside of the function attached to the x, we multiply all the x values of our normal ordered pairs that we have memorized. We multiply the x values by 1/a. Okay, let me point something out here too. You probably have been thinking this and like rolling your eyes at me a little bit. You might be like, well, this is the same as this, and I already know a rule for that, right? I know this rule from Algebra 2. So do you see how just simplifying the square root of 4 turns it into an Algebra 2 trig problem instead of an honors pre-calc problem? That's totally fine. I would do the same thing. But there are going to be times like in this example right here where we can't do that, okay? Same thing with like, if I have, for some reason, if the book tried to give me something like that, which I don't think they would because that's an unsimplified equation, that would be multiplying the x values by 1/2 or simplifying it and multiplying the y values by 4. Either of those things would give you the same graph. In fact, I would encourage you, I'm not going to say it's a required. I really got to figure out how to stop making this table bounce, don't I? Goodness gracious. Okay. I would encourage you to do both of those. Take your normal x squared points and multiply the x values by 1/2. And then on the same graph, take your normal x squared points and multiply the y values by 4, and you'll see that those are all going to make a nice pretty parabola, one parabola. Okay, all right, so let's do this. So actually I'm not even going to plot the points. So I'm going to start with my parent function, which is the square root of x, and the ordered pairs that I use for my parent function that I have memorized from Algebra 2 trig. And I'm going to multiply those y values, I'm going to multiply those x values by 1/3. I'm just applying this rule right here, multiplying those x values. So this x value stays the same. So remember, when I'm multiplying the x values, the y values stay the same. When I'm multiplying the y values, the x values stay the same, okay? Multiplying the x by 1/3 and multiplying the x by 1/3, and then I would just plot those points. on a graph. And that's it. Oh my goodness, under 10 minutes. Stop now.